Simplifying radicals with variables. Simplifying radicals with variables is similar to simplifying radicals with numbers. So let's take a look. So the square root of 9 we know is the square root of 3 times 3. There's one pair of 3's, so the square root of 9 is 3. So the square root of x squared, well, the square root of x squared is x times x. There's one pair of x's under the radicand, so the square root of x squared is x. The square root of x to the fourth can be written as x times x times x times x. So there's two pairs of x squares underneath the radicand. So the square root of x to the fourth is x squared. The square root of x to the sixth, the square root x to the sixth is x times x times x times x times x times x. There are three pairs of x's under the radicand. So the square root of x to the sixth is x to the third. So let's look at a pattern here. We had x squared. We divided 2, we got x to the 1. X to the 4 divided by 2 is 2. X to the 6 divided by 2 is 3. So the square root of x to 100 is x to the 50. We take the exponent and divide it by 2 because there's 50 pairs of x's under the radicand. So those are all even exponents. But what happens when we have an odd exponent? Well, let's look at the number first. Here we have a square root of 27, which we can write as the square root of 3 times the square root of 3 times the square root of 3. There's one pair of 3's and 3 left over. So the square root of 27 is 3 square roots of 3. We brought out the pair and left one under. So what happens with the square root of x cubed? The square root of x cubed is x times x times x. We have one pair with one left over. The square root of x to the fifth, x times x, x times x times x. We have two pairs with one left over. X to the seventh, well, instead of writing it out, can I just divide this by 2? 7 divided by 2 is 3 with 1 left over. X, the square root of x to the ninth. 9 divided by 2 is 4 with 1 left over. So to determine the number of pairs, we divide by 2. And if the exponent is even, there's nothing left under the radicand. But if the exponent is odd, then there's one left under the radicand. So let's practice some. So here we have the square root of 45x times y squared. So let's rewrite this. Let's think of this as separate. We have the square root of 45 times the square root of x times the square root of y squared. So 45 can be written as the square root of 9 times the square root of 5, which is 3 square roots of 5. So that's our number. The square root of x, well, there's no pairs under there, so it's just the square root of x. And the square root of y squared, well, 2 divided by 2 is 1 with none left over, so I have a y. So what do I have on the outside? I have a 3 and a y, so my answer is 3y. And what's under the radicand? A 5 and an x. So here's our 3 square roots are 5, our x stayed under, and our y came out. Let's try another one. Okay, let's look at this one. This could be rewritten as the square root of 16 times the square root of a squared times the square root of b squared. The square root of 16 is 4. The square root of a squared is a. And the square root of b squared is b. So our answer is 4ab. Okay, number 7, the square root of 54 times the square root of x times the square root of y. So 54 could be written as the square root of 9 times the square root of 6, which is 3 square roots of 6. And neither of those have a pair, so our answer is 3 times the square root of 6xy. Let's try number 8. So we have the square root of 45 times the square root of x squared times the square root of y squared. Square root of 45 is square root of 9 times the square root of 5, which is 3 square roots of 5. The square root of x squared is x, and the square root of y squared is y. So my final answer is 3xy times the square root of 5. All right, let's take it up. Now we got 3 variables. So let's rewrite that. We have the square root of 12, which is square root of 4 times the square root of 3, which is 2 square roots of 3. The square root of m squared is m. And then I have the square root of p, which is the square root of p. And the square root of q, which is the square root of q. So what do I have on the outside? I have a 2 and an m, square roots of 3pq. Last example, number 10. We have the square root of 8, which is the square root of 4, times the square root of 2, which is 2 square roots of 2. Square root of x squared, which is x. Square root of y squared, which is y. And the square root of z, which is the square root of z. So what do I have on the outside? I have a 2xy, and under the radican, I have a 2 and a z.